Hello, my name is Bob Thorne and I'm a Senior Applications Engineer here at Radan. Now I'm here today to tell you all about Radan 2018 R1, which is the latest release of our CAD/CAM software. Now this year we decided to go back to 2 software releases. So in 6 months' time we'll be talking about Radan 2018 R2. But for now, just let me get on and show you the new features and functions of Radan 2018 R1. Now there's lots in this release of software, so in this video I won't be able to go through everything in detail. But if you'd like a detailed description on what's in this particular release, you can do this by going to your Help, Radan 2018 R1 Help, and in the Recent Enhancements section you will get a detailed description of all of the new features and functions in this particular release. Radan 2018 R1 will only run on a true 64-bit operating system. You can see on screen a list of supported operating systems, but if you have any doubts about your own operating system, please contact your support before installing your Radan 2018 R1. The CLS key, or golden key as it is sometimes referred to, will no longer be found in your hidden icons area on your desktop. Instead, links to the license manager and configure licenses can now be found in the Start menu under Radan or in System Info. Okay, let me show you where these are. So in my Start menu, under my Radan software, if I scroll down, you will see I've now got a new entry called Radan 2018 R1 License Manager. This will take me to the License Manager where I can manage my licenses in the normal way. Alternatively, again under the Radan software area of my Start menu, if I scroll down and find my SIS Info, you will see on the SIS Info dialog I have a Configure Network License and a link to the License Manager. Remote support is often the most efficient way for an engineer to help an end user with a query. Now Radan used TeamViewer to assist with remote support. So in Radan 2018 R1 we now have a link which will automatically start a TeamViewer session from within the software. I'm just going to very quickly show you how to initiate a TeamViewer session. So you see here in the Help menu I can scroll down to an item Remote Support, select that, and that will initiate a TeamViewer session where I can then get connected to Radan support. Another way to initiate a TeamViewer session is to find your SIS Info, and you'll see there's a big button here, Remote Support, and again by selecting this you will initiate a TeamViewer session to connect to your Radan support. With all new releases of software we always look at the import and export formats that we can support. In Radan 2018 R1 we can now import AutoCAD 2018 DXF and DWG files. We've also looked at 3D import formats, and on screen you can see a list of the systems that we can import files from. This is a new feature for Radan 3D. In your 3D sheet metal part, if you have any holes that have chamfers or forms on them, when you develop them, those holes will be represented by two profiles. An inner profile for the hole and an outer profile to show the form or chamfer. Now the inner profile will be specified by a pen defined for inner profiles, and the outer profile will be specified by a pen for forms. In the simple 3D image you can see on screen, I have two holes, one with the form and one with the chamfer. This second image shows that same 3D part developed flat, and as you can see we are displaying the holes, the inner holes, with a green pen, and the forms with a different color pen and a different line style. Alright, let me show you this in a simple demo. Here on screen you can see a 3D sheet metal image, and I've got three large holes. As I develop it flat, you can see that I've just got the three green circles indicating the holes in the flat blank. I'm now going to add some forms to these holes. So I'm going to start with a simple radius. So there you can see the radius on the part. And then I'll also add another radius to the back of the part, so we've now got two radii on the two separate holes. And then finally I'm going to place a chamfer, a large chamfer, on the top hole there. So now let's develop that part into Radan 2D, and there you can see I've got the three holes indicated by the green lines, and then the forms indicated by my dotted red line on the outside. Now these particular line styles are set up, you see, in your output settings. Under forms you can select the pen color and the line type to display these forms. In Radan 2018 R1 we have improved the way we select 2D features. When you are working in drafting, tooling, manual nesting, the way in which the features are selected for editing operations, i.e. delete, move, jump, cursor, etc., this has been improved. The selected feature, indicated by the highlighting, is now simply the nearest one to the cursor. Let me explain this change. In your previous version, Radan 2017, when you had a line, there was an imaginary circle which encompassed this line. So if you wanted to select this line for editing or deleting, your cursor had to be within this bound of influence, i.e. inside the circle. Now you can imagine if you had multiple lines, this would then potentially cause confusion because you had multiple circles of influence. In Radan 2018 R1, these zones of influence have gone. So now when editing 2D geometry, you are simply affecting the item closest to the cursor. Let me see if I can show you this in a simple demonstration. I've gone into delete mode, and as you can see I've got a selection of lines and arcs on screen. Now without moving my cursor, by hitting the delete key, I am just deleting the nearest item to the cursor, and gradually they are moving outwards from the center. So I'm no longer relying on any zone of influence to delete these features, it's purely the one that's closest to the cursor. Querying features in 2D. The 2D query dialog has been improved by the addition of buttons for querying particular types of feature. In particular, this makes it much easier to query symbols, because only symbols can be selected and not the lines and arcs inside them. An additional button has been added for the querying of angles between three selected points. On screen you can see an image of the new 2D query dialog with the symbol icon selected. I can now select a symbol without worrying about picking up lines or arcs within that symbol. And having selected that symbol, I will get some detailed information about that particular symbol. The second new feature in the 2D query option is the query of an angle between 3 points. So here you can see I've selected the icon, and the workflow to select the angle is simply to pick the intersection point first, so that's pick 1, and then any point on the end of the line or the mid portion of the line will give me the angle between those 3 points. So again, I could pick the intersection and anywhere along those lines to give me the angle between those 3 points. Let me see if I can demonstrate a few of these features in a simple demonstration. Now firstly, by the fact that we can actually pick the nearest item to the cursor, in nesting mode when moving symbols, I'm no longer having to find the origin of the symbol. I can simply select anywhere close to the symbol that I want to move, and that is the symbol that will move. So doing some manual adjustments in nesting is much easier in Radan 2018 R1. Right, let's have a look at the query symbol feature. So in my query dialog box, you can see I've got a new icon for querying symbols. And now by selecting, I will select the closest symbol to my cursor, and I will be given information about that symbol. So again, I don't have to find the hook point of the symbol, the origin point of the symbol. I can simply select the closest symbol to my cursor. Right, let's now have a look at the new query between 3 points option. So I've got some geometry on screen, and again the workflow is select the intersection point and then 2 other points, and I will be given the angle between those 3 points. So intersection, first point, second point, and there is the angle. Now again, as I said before, you don't have to pick the end point. It can be anywhere along the line in order to display the angle between those 3 points. So intersection point, first point, second point, and there's the angle. Improved nest images on reports. When using reports in setup sheets or nest project reports, the images of the nests have been improved to use the available space more efficiently. More nest information has been made available to reports, and these include sheet weights and time estimate data. So here you can see a typical report with the improved graphics of the nest layout. So let me demonstrate this. Here on screen you can see I've got a nest project. If I generate the reports for this nest project, hopefully you will see that as I scroll down to my nest layouts, I will have an improved quality of image on these reports. So we're using more of the available space to display this nest layout. Add sheets to nest projects. A new button and context menu have been added to the Sheets tab in project nesting. This will automatically add any valid sheets which have the same material and thickness from parts in the Parts tab more effectively. So the image on screen shows the Sheets tab, and there you can see the new button that will update the sheets based on the parts that you have in your Parts tab. So again, I'm just going to demonstrate this. So here in my project nest you can see the parts.
I currently don't have any sheets available, so by selecting this new icon I can put the appropriate sheets based around the parts that are in my part tab. Kits in nesting. In the part editor, when the user creates a symbol that only contains parts, the software now assumes that the user is making a kit. In this case, a message comes up when saving the part to confirm this. So here you can see the image displaying is saying, is this a kit of parts? If the user selects yes, then the symbol will be saved away with a flag indicating that it is in actual fact a kit. If you say no, then it will just be saved as a standard symbol. This kit attribute is used later on when adding this to a Nest project. So again, let me demonstrate this. So I'm going to create a simple kit by simply selecting some existing symbols. By placing down a symbol more than once indicates the number of symbols that I want in this kit. So you can see here that when I've hit the save button, the system is asking me, is this a kit of parts? If I respond yes, then the attribute will be set to make this a kit. So I'm just going to save this kit away, and then we'll bring this into a project. So here you can see I've got a Nest project. I'm now going to add some parts. If I browse to the part that I've just created, you'll see that by default the kit of parts has now been selected in the Add Parts dialog, saving me the need to do this. And then when I apply this, these parts will be added to the project in a normal way.
In every release of software, we try to improve the nesting capabilities. In Radan 2018 R1, we now offer a new approach to nesting that focuses on optimizing the utilization across a batch of nests, i.e. multiple nests. The new option is currently only available for profiling machines, but can be found in the multi-part nesting dialog. Here you can see the multi-part nesting dialog, and here I've highlighted the new option to optimize batches of nests. Unfortunately, there are a number of nesting functions that are not yet available when using the new batch mode, most notably tool checking. This is why this particular batch nesting is not suitable for punching machines. Right, now this really does deserve a demonstration, so let me show you how the new batch mode works. So I'm going to load up a project. I've got some example projects here, so I'm just going to show you this one. So here you can see a list of components that I'm going to use to nest into some sheets. Now in my nesting options under true shape, I'm going to use 2 seconds to nest these components. So this is using the current nester in Radan 2017. Now as you can see the nests appearing, some pretty good utilizations there. We'll let this complete set finish. And if we have a look at the nesting options output, what we have is 6 programs and 60 sheets used to nest this set of components. Just show you a few of these nests.
As I say, some pretty good yields out of these sheets. Now I'm going to delete these nests and we'll rerun the same set of components, but this time using the new batch nester. So again, if I go into my nesting options, I will now switch on the batch option, and to make the test fair, I'm going to give it 12 seconds to complete the nests. So again, you can see I've got 6 programs, but on this occasion I've got 57 sheets. So you can see the standard nester of 2017 was 60 sheets, the new batch mode in 2018 R1 is 57 sheets. And again, I'll just show you some of those nests created. Right, I'm just going to call up one other example to show you, because we really are quite excited about the results we're getting from this new batch nesting. And we have done many trials, and in most cases we are outperforming the existing nester quite considerably. So in this second example, you can see I've just got one component, and I'm going to nest it using the traditional 2017 nester, and I've given it 30 seconds to nest this single component into a sheet. So there you can see the nests arrived. Again, some pretty good yields, but let's have a look. So we've got 2 sheets, 2 programs. But I'm more interested in looking at the nest that we've generated. So we'll go into the first nest, and you can see there we've got nest number 1. And if we look there, we've got 34 components in that sheet. So I'm now going to delete these nests, and we'll run the same component through the new batch nester. So again, in nesting options, I can just select optimize batches of nests, and I've given it the same 30 seconds to produce the nests. Now I've deliberately left this at real time so you can actually see the length of time that these nests are taking to create. So we're going to give it the full 30 seconds to complete this nest. Now again, still 2 sheets, 2 programs, but let's have a look at the first nest that was created. So I think you'll agree, a much better layout of the components. And as you can see here, I've now got 40 components in the sheet. In profiling, we've now added etching of smart hatching. Smart hatching drawn in the etch pen is now automatically etched in automatic tooling. There is no need to realize the hatching. So let me demonstrate this very quickly to you. So I'm going to recall a symbol. In this case, I've got a symbol of the Radan logo, and I'm now going to apply some smart hatching to this profile. I'm going to change the pen color of the hatching to my etch pen, and I'm now going to go into auto tooling and just simply hit apply, and as you can see, auto tooling as in actual fact tooled the hatch lines without the need for me to actually realize the hatching into the part. Rules for automatic filleting. Automatic filleting on profile machines can now be controlled using rules in the automatic tooling dialog box. You see here highlighted there is an option for fillets, and here you can see we have the filleting properties, which can be stored in your manufacturing database. Right, let me do a quick demonstration of this. On screen you can see I've got a component. I'm going to add some laser profiling to this. And in my auto tooling dialog box you can see there's my entry for my fillets. So if I apply this without fillets, and I just zoom in to show you that, you can see the auto tooling has in fact applied a profile around this true geometry shape. I'm now going into my auto tooling dialog and switching on the auto filleting options, which will read the properties from my manufacturing database. Now applying the profile, you can see that I've automatically filleted these profiles. So this can be stored in my manufacturing database against a machine and material combination. Scrap cutting for internals on combi machines. Automatic tooling on combi machines now automatically can scrap internal profiles. This was available on traditional profiling machines, but we've now added this to combi machines. So again, I'm going to do a very quick demonstration. You can see with the same component here, I've got my internal profiles, and I'm going to automatically tool that for a combination machine, and here you can see the scrap cuts applied, including the pre-punch piercing for my particular combi machine. Tagged profiles. Auto tooling profiles tagged mid-feature only will no longer be tooled with an additional lead at the vertex, unless an L datum is present or tags are without leads. Scan cutting. When auto tooling with smart ordering, linear slots that will be fly cut are no longer split mid-feature. Fillets for undercuts. Fillets can now be automatically applied to undercut lead-ins. You can see here on screen my rules and styles dialog, and there you can see I have an option to specify the fillet radius for an undercut lead-in. Offcuts. In Radan 2018 R1 there are now two new options for cutting off remnants that have been added to RAD profile. Here you can see my sheet scrapping dialog. So where before we had 4 options, you can see we've now got 6. So there's 2 new options for generating sheet offcuts in RAD profile. Here on screen is the example, the first example, where the remnant is cut into a series of rectangular shapes based on my required sizes. So this will generate rectangular remnants and offcuts. The second of these options is to actually create a profile that matches the last components on the sheet, giving you the maximum size offcut. Right, I'm just going to very quickly demonstrate this. So I've got a nest on screen. Now to create some scrap, I'm going to actually delete some components, and you can see here with the new selection option, by using the crossing window, I can very easily delete those symbols. So I'm now going to use the sheet scrapping dialog to actually create some rectangular scrap based on the remnant that's remaining. And as you can see here, I've got 4 standard rectangular shapes which are going to be used for scrapping the sheet. Using the second option, I will create as true a shape using horizontal and vertical lines to create a remnant of this material. Punching offcut control. For punching machines, it is now possible to auto-order parts and offcuts separately in order mode, even when they use the same tools. This is done by specifying a window punch command in the auto order style. The window punch command may use the following options. Offcuts means do the offcuts tooling features. No offcuts means do all tooling features except offcuts. In the order text itself, the window punch command may optionally be followed by the appropriate keywords. As you can see in this example. You see here on screen I've got my auto order editing, and you can see there's some options there: only offcuts or ignore offcuts. Let me demonstrate this to you. So on screen I've got a very simple nest with some components, and if I go into order mode you will see that I've got some slitting as a final operation to create the offcuts. So I'm going to auto order this with the no offcuts option, so you can see that all the components have been ordered but not the offcuts. I can then, using a different auto order text file, switch and say do the offcuts. So let's have a quick look at that auto order file, and if I just scroll down you'll see that there in my options there I've got ignore offcuts, and then in this one I've got include offcuts, or offcuts only. General camp. When changing machine tool, the strategy, if applicable, and standard tool loading file will be updated to their current values for the selected machine, or to the manufacturing database system data specified default values if they have not been set for the selected machine. The tooling and annotation on the nest for a selected machine will also be shown. If the selected machine supports strategies, then you can also change the currently selected strategy using the Change Strategy button. If the standard tool loading file is not yet been set for this machine, then it will be updated to its manufacturing database system data specific default value, if it has already been set. But to a value different to its manufacturing system data specified default value, then the software will ask whether or not to continue using the value already set.